This video is brought to you by Factory Direct Trains. Visit factorydirecttrains.com and check out their wide selection of model railroading products and supplies. Hey everybody, it's Jimmy from the DIY and Digital, and today it's the Arduino multi-block signal system. Welcome back everybody. First of all, if you haven't already, go ahead and hit that subscribe button so that you are eligible for the 5,000 subscriber contest sponsored by Factory Direct Trains. I'm giving away an N-Scale Broadway Limited T1 with DCC and Paragon 3 sound, and I'm also giving away an HO-Scale Athearn DCC Ready GE-9 in the Union Pacific Chicago Northwestern paint scheme, and you do have to be a subscriber to be eligible for that contest. And while you're at it, go ahead and hit that like button and hit that bell icon so that you don't miss any updates. If you want to enter that contest, I'll put a link in the description below. Today's episode, we are tackling something that I know a lot of you have been waiting for ever since the tutorial with the original Arduino-based block signal. Today, we are doing the building instructions for the Arduino multi-block signal system. Before I begin the actual build, I wanted to explain a few things about why I am doing some things a certain way and what my process is. The first thing is how I wanted the system to be constructed. There are several ways I could have gone about this. One of the easiest to conceive, but longest to code, would have been to use an Arduino Mega with its additional I/O pins. But I decided against this because it still limits the number of blocks on the system. I wanted a system that could theoretically have an unlimited number of blocks connected to it. The system that I came up with was daisy chaining multiple Arduinos together so that each individual Arduino controlled the signals and the sensors for an individual block. Now this required me figuring out a communication system between the different Arduinos so that one Arduino could tell the adjacent Arduinos when the block was occupied. I needed the Arduino to send out a signal when it was occupied to the blocks in either direction so that they could indicate to any train that the next block was occupied. I then needed the Arduino to register the signal and change the appropriate signal from green to yellow. Now the Arduino has several built-in ways for communication. The first is serial communication, which it does through the USB connection as well as the RX and TX pins on any given Arduino. I tried this first using Arduino Megas, which have multiple serial inputs and outputs. This worked, but it was a bit too complicated for the simple system that I wanted. The next system that I considered was wire communication, which involves a bus system where all signals are sent through a master Arduino. And this one I could never get really to work out the way that I wanted it to. All I really needed was a way to send a change of a signal from one Arduino to another. And this led me to analog communication. After some research, I discovered that if I set a digital pin as an output on one Arduino and connected it to an analog pin that acted as an input on the other, I could turn the digital pin on and off and it would register on the analog input as a change. So now I have my simple communication system, and now I just need to figure out the type of code that I would need to make this whole system work. The main difference between this system and the original block signal is that I needed to control each signal individually rather than together. My plan for this involved increasing the number of signal states in the Arduino program from 5 states to 7, and giving them the ability to hop back and forth in between each other. Now that we've established all the requirements for the system, let's go to the parts that we're going to need for this build. The first thing that I will need is an Arduino. I will be using an Arduino Uno on the demonstration build, but you can use any type of Arduino that you wish. I will also need a breadboard, 2 infrared sensors, 6 LEDs, 2 red, 2 yellow, and 2 green, and a bunch of wires with DuPont connectors. So let's get started with the build. If you like schematics versus simple instructions, I will have this schematic available in the description below. The first thing we are going to do is place our sensors and LEDs into position on the board. Remember that the LEDs need to share a common positive, so place them accordingly. Next, we'll go ahead and wire up our breadboard power connections. And now we can begin wiring things to the Arduino. We will be using digital pins 2 through 7 for each of the LEDs, with pins 2, 3, and 4 being used for green, yellow, and red lights respectively on signal 1, and pins 5, 6, and 7 being used for green, yellow, and red lights respectively on signal 2. We will be using the 5-volt connection as the common positive for both of these signals. We hook up the power wires from the Arduino to the breadboard so it can power the LEDs and the infrared sensors. Now it's time to hook up the LEDs to the digital pins. Remember, we're going to be using the ground of the LEDs to hook into the digital pins. And the green, yellow, and red of signal 1 will be hooked into 2, 3, and 4. And the green, yellow, and red of signal 2 will be hooked into 5, 6, and 7 respectively. We then connect the outputs from the infrared sensors to analog pins A0 and A1 for sensor position 1 and 2 respectively. After that is done, it's time to connect the communication wires. We will be using digital pins 8 and 9 for this. The wire that is hooked up to pin 8 will go to the block that is prior to this one in the sequence, and the wire that is hooked up to pin 9 will go to the block ahead of this one in the sequence. Pin 8 will hook into analog pin A3 on the previous Arduino, and pin 9 will hook into analog pin A2 on the next Arduino in the sequence. The last thing that we need to do is hook up the common ground that's going to be shared between the entire block system. That's all the wiring that's required to set up one of the blocks in the multi-block signal system. You will have to do this for each block on the system. Now, let's hop over to the computer and write some code. Okay everyone, we're in our Arduino IDE, and first of all, as always, we're going to be setting up our integers. So the first one we're going to do is int sensor 1 equals A0, and that as always means that you'll have sensor 1 is set up on pin A0. Then we'll do int sensor 2 equals A1, and that will be sensor 2 is set up on pin A1. The next thing we need to do is we're going to set up the pins for our LEDs. So we're going to do int green 1 equals 2, and that is green signal 1 is digital pin 2. Then we need to do yellow 1 equals 3, and that is yellow signal 1 is digital pin 3, and then integer red 1 equals 4 is red signal 1 is digital pin 4. Then we need to do integer green 2 equals 5, And then we'll do green signal 2 is digital pin 5. Integer yellow 2 equals 6. Yellow signal 1 is digital pin 6. And integer red 2 equals 7. And that is red signal 2 is digital pin 7. Okay, so the reason that we're doing two separate sets of green, yellow, and red signals is because we have to control the signals on the block individually so that we can signal certain directions are yellow versus green for when the next block is occupied. So we're going to go into the communication system now, and we're going to do integer block A send equals 8. And what that is the transmit pin for the previous block in the sequence. Then we're going to do integer block B send equals 9. And that's going to be the transmit pin for the next block in the sequence. Then we need to do integer block A receive equals A2. And that's going to be the receive pin for the previous block in the sequence. And integer block B receive equals A3. And that's going to be receive pin for the next block in the sequence. So those are all of the integers that we need to set up. So we can go ahead and actually go into the setup process for the actual Arduino loop. So we're going to do void setup and do our brackets. And the first thing we're going to do is we're going to start the serial process just for any sort of testing and tweaking. We always do serial communication, and we do the serial begin of 9600. Okay, now we need to establish our pin mode. So we're going to go ahead and say that we're going to establish all of our pins as inputs or outputs. So now we're going to do pin mode sensor 1 is an input. Pin mode sensor 2 is an input. Pin mode green 1 as an output. Pin mode yellow 1 as an output. Pin mode red 1 as an output. Pin mode green 2 as an output. Pin mode yellow 2 as an output. And pin mode red 2 as an output. Then we need to do our transmission and receive pins. So we're going to do pin mode block A send as an output. Pin mode block B send as an output. Then we're going to do pin mode, block A receive as an input, and pin mode, block B receive as an input. So those are all of our pin modes. So now we can go ahead and close out those brackets. Let me see if there are brackets already closed because of the formatting. And now we need to enumerate our signal states. So we're going to go ahead and type enum signal states. And then we're going to put a bracket. And now we're going to be doing 7 different signal states versus the 5 from the previous signal system that we discussed. So we're going to do st_gg, and what that is green green. So both signals are each green. So 1 is green, 2 is green. Then we're going to do _gy, which is 1 is green, 1 is yellow. Then we're going to do st_yg. So the other one is yellow and the other one's green. Then we're going to do st_yy, so both signals are yellow. And then we're going to do st_rr1, so that's the state number 1 for both signals being red. Then st_rr2, the second state for both signals being red, and then st_rr3 for both signals being red. So there's 3 different red states, and then there's also 4 different green or yellow-green variant states. So that is all of that. I'm going to put those notes right there. Let me, so we'll say sets up the gotta put my slashes there. So sets up different signal states for the entire program. And then we need to say that signal states, signal state equals st_gg. And that sets the, that's going to set the default state to green and green. So it's always going to start on green and green. So now we can go ahead and hop into the loop, so which is going to be the majority of our program. So we're going to do void loop. And the first thing we're going to do is we're going to set up all of the sensor readings for our serial, so when we hook it up to a computer we can tweak it. So let's go ahead and do integer value A1 equals analog read sensor 1. Integer value A2 equals analog read sensor 2. Integer value A3 equals analog read block A receive. And integer value A4 equals analog read block B receive. And what this is sets up all the values of the different signals we will be reading. Then we'll need to do serial.println value A1, serial.println value A2, serial.println value A3 and serial.println value A4. And what that does is we're going to say that sets up the different values to be read on the serial monitor in the Arduino IDE. All right. And then after all of that, we're going to put a delay of half a second on it. And then we're going to start the switch to go to our different states. So we're going to do switch signal state. Then we're going to do our bracket, and we're going to do case st_gg regular colon signal gg value A1 value A2 value A3 and value A4. Break. So instead of just completely like typing this over and over and over again, I'm just going to copy paste all of this. So we're going to do each one and we're going to adjust it. All I have to do is just change it for what it is. So to green yellow, then yellow green, and yellow yellow, and RR1. And I'm actually going to copy this one, and then we're going to do RR2. And RR3. And what that's doing is this sets up all the different little miniature loops that are within the main loop for our different signal states. So it's going to be able to hop in between. And it's also telling us which integers it's going to be looking at in the signal state. So now we can go ahead and start hopping into the actual signal states. So let's go ahead and do that. So now we're going to go ahead and start void signal GG. We're going to do integer value A1, integer value A2, integer value A3, and integer value A4. And we're going to put our brackets. Now we're going to do our actual light control. So we have digital right, green 1, low. Now remember that we are doing the pins that are controlling the lights for the LEDs are actually going to be the ground because it's sharing a common positive. So we need to do low instead of high. We're just doing the opposite there. We're going to do sets green 1, 2 on. Then we're going to digital right yellow 1, high. Digital write red 1, high. Digital write green 2, low, just like green 1. And sets green 2 to on. Digital write yellow 2 to high. Digital write red 2 to high. And then we'll need to do analog write block A send 0. And this means that that will not transmit a signal to block A. And then we do block B send 0. And this will not transmit a signal to block B. All right, and then we'll put a delay of ½ a second. And now we need to get into the if-then statement. So what we're going to do is we're going to go ahead and start off with that. We're going to go if value A1. We're actually going to put these all in parentheses so that just in case the program were to get a little confused, we have everything separated out. So if value A1 is greater than 500, and remember, and is double ampersand, value A2 is greater than 500, which means that the signals have not been tripped, and value A3 is less than 300. We want that value to be really, really low. Let me put the parentheses there. And value A4 is greater than 300. Signal state equals st_gy. So what we're saying here is that if the signal is clear, if the actual block is clear, nothing has stripped the block, but you're getting a signal from the block ahead saying that it is occupied, it's going to trip the appropriate signal, which is going to be one of the yellows, to green yellow. So we're going to put block not occupied, but block B is. And I just saw a little bit of a formatting error, so we're going to change that. So that's that one. We're just going to copy paste and readjust it. So there's that. And we're just going to be switching this one over to yellow green. So we just need to flip flop the greater than or less than signals. And this is going to be for if the previous block is occupied. Then we need to do if both of blocks on each side are occupied. I know it's something that probably won't happen, but unless you have a larger system, but we need to go ahead and do that just so that it is available for a larger block system. And block A R. And then last but not least, we're just going to copy part of this. And we're going to say if value A1 is less than 500, which means that the signal has been tripped. So that is going straight into red. And we're going to put that there, and we're going to say and then we'll need to and that's saying it's entered and tripped on sensor 1. Now we just need to reverse. And we're going to say that that goes to RR2. So that is an entire signal state right there. So what we're looking at here is we have both the green, so this is signal green, green. So green 1 and green 2 are on, the rest of them are off. And the occupation transmit is not transmitting because it's at 0. And then we have the different signal states. If an adjacent block, if block B is occupied, it's going to transmit and switch to green yellow. If block A is occupied, it's going to transmit it to yellow green or change to yellow green. If both block A and B are occupied, it's going to change it to yellow yellow. If the block is occupied, then it'll switch it to red 1 if it was entered from sensor 1. And if it was entered from sensor 2, it'll go to signal state RR2. So that's going to be the basic setup for 4 of the 7 signal states. So what we're going to do is we're just going to copy. And we're going to paste. And we're going to start off with green, yellow, which means that we need to change out our number 2 signal to being yellow. We're just going to say that sets yellow 2 to on. So what we're going to do is we're just going to switch this one right here. We're going to switch that to less than, and that's all we need to do right there. So, because everything else is pretty much the same, so we can have it hopping back and forth. So let's see here. And we're going to say so let's go through this really quick. We do have the number 1 signal, the green 1, set to on. Then we also have yellow 2 set to on. And we're still not transmitting. And the only thing we really change is where it was green yellow, it's going to be going back to green green if the block A and block B receive, which are value A3 and A4, all of a sudden are not receiving a signal. So if they go down to 0, they're not going to be receiving a signal, and everything else pretty much stays the same because you still want to be able to hop over to yellow green, you still want to be able to hop over to yellow yellow, and red 1 and red 2. So everything else pretty much stays the same. So we're going to copy this. And we're going to paste it again, and we're going to do the few minor changes. We're going to do yellow green. And we're going to change this to green yellow. Well, first of all, we'll do that. Let's actually just leave that be, and then we're going to change this to green yellow. And we're going to say what block B is, and then all we have to do is flip the value A3 and value A4. And we'll just double check and make sure that matches up for the green yellow trigger. It does. And then we just need to switch out our LEDs. mistype there. Okay, so what we have here is we have signal yellow green, so the number 1 signal is at yellow. Okay, so signal YG, yellow green, so the number 1 signal, yellow one, is going to be set to yellow, and then the number 2 signal is going to be set to green, and it's still not transmitting. In order to go back to green-green, everything has to be the same way it was with green-yellow. And in order to go to green-yellow, it just has to be the same way it was that it has been. You just have to flip-flop the value A3 and value A4. And then to go to yellow-yellow, it's going to have to be value A3 and A4 are both tripped. And then red 1 and red 2 are exactly the same. So we're going to go ahead and copy this. Now we're going to be doing yellow, yellow, which has a few more changes. And then we're going to set that to... This is where both of the yellow, yellows are on. So we're going to just change these out. And we just need to eliminate the yellow, yellow so it can go back to yellow, green, and we just need to make it the opposite of green, yellow. So that one was actually correct. We can leave that one there, and then we can just flip-flop that one. And that's pretty much all the changes. So it's going to be both yellows are on for 1 and 2. It's still not transmitting. If it needs to go back to green, green, everything has to go back the same way. Needs to go back to yellow, yellow, same way. Yellow, green, same way. R1, R2, all the same way. So now we can go ahead and we're going to copy this, but we're going to be doing a lot more modification for the red signals, which we're about to do. So we're going to go ahead and add RR1. So the first thing that we need to do with RR1 is we need to change the LEDs. And we're going to go ahead and delete those out. And we're going to say that this sets red 1 to on. And this sets red 2 to on. The other big change that we need to do is we need to go ahead and set our block A transmission pins to 1023. And this will transmit a signal to block A and block B, notifying them that this block is occupied. Now we can go into our if-then statements. So we're going to do if value A1 is greater than 500, value A1 is greater than 500, and value A2 is less than 500, we're going to say signal state equals st underscore rr3. And that switches to our transition red signal state, which is rr3. And that is actually it for red 1. So we're going to go ahead and copy this. And all we have to do is switch this to red 2 and then reverse our greater than and less than signs. And that'll switch to RR3. And then we're going to copy paste it again, switch it to RR3. And then we're going to say if value A1 and value 2 are both greater than 500, that means it's cleared. So instead of going to RR3, obviously it can't go to itself. It's going to switch to green, green, which from that point it can go to green, yellow, yellow, green, yellow, yellow fairly quickly. So that is the entire code for this block signal system. I know that was a whole lot. I'm going to have the entire code available in the description below. Let's go ahead and check it out and make sure it works. And there we go. We have the entire Arduino block signal system checked out. We're going to go ahead and upload this into our Arduinos, and we're going to go test it out. Now we have the same code loaded up in all three of these Arduinos, one Uno and two Megas. I did this so that you can see that this will work in any Arduino. And I also have them hooked up in a circle, which is how they will be hooked up on my actual layout. So let's go ahead and give this a shot. As you can see, when I trip one block, the other two blocks act accordingly with the appropriate signal, and you can see that they hop back and forth between the different signal states. It also works in both directions. So that is the long-awaited Arduino multi-block signaling system. I hope you guys really enjoyed it. I'd love to know how you guys tackle your own multi-block signaling system. Leave that in the comments below. And if you haven't already, go ahead and hit that subscribe button, hit that like button, and hit that bell icon so that you don't miss any updates, including when I do more stuff with the Arduino multi-block signal system. Until next time, I'm Jimmy from the DIY and Digital. Happy railroading!